Hey everyone, welcome to the session Securing 5G Frontier Real Threats, Deepfakes, and Defense Strategies. Just to introduce myself in the start, I'm the founder of X Security Pulse, lead author of Cloud Security Alliance. I've been also working with ARAN Alliance for different working groups. I'm also honored to have authored courses on LinkedIn Learning, EC Council, and also have contributed to the standards and other working groups to contribute to the telecom security industry. Uh, it's been my pleasure. Before we start, I just want to quickly go through the agenda. What are we covering today? So there are six important topics which I'll take you through. We'll start with the basics, like why 5G security is critical now and why it is so much important, and why there is so much interest these days. Then we'll touch briefly on the 5G threat landscape to take you through different attack vectors, different attack patterns, case studies to what is happening around the stage in the 5G landscape. We'll zoom in into the deep fake driven attacks, especially because these are some of the most common attacks these days. And there's a lot of impact that is happening, with our daily day-to-day life during due to these attacks. And then to emphasize and to explain all this so that you understand where it is coming from, how we can detect, prevent, and catch these attacks early, we will go through some live demo scenarios which I have prepared for you, which will exactly tell you how these attacks are carried out, how the attackers move laterally inside the network, and how you can better equipped and prepared to handle these attacks. And then in the last topic, we will go through some of the defense playbooks that will help you to be better prepared. So if you are in the telecom industry or if you are from cybersecurity field, this is will be going to be very interesting for you, to see all these things live. And lastly, we'll go through some call to action in which we will tell you like the next steps that what you can take to be better prepared, and how this can help you in your routine life as well as in the industry that you're working on. So before any delay, let's go deep dive and let's go straight in. So why 5G security matters? So there is previously when 5G came into the telecom space, it's all about speed, and there are use cases coming up, interesting use cases, I would say, coming in with the introduction of 5G, such as network slicing, XR/VR, 4K, 8Ks, But now, if you look at the 5G landscape now, it's no longer a hype. It has proven a solid enabler of critical sectors, such as smart factories, autonomous vehicles, healthcare, defenses, and like think about this as a communication channel. Within any industry, one of the most important thing they do is they communicate data, and how the data can travel faster. If you want data to be efficient, you want data to travel across different paths fastly, you want better throughput, you need an enabling infrastructure, and that is what 5G gives to the table, brings to the table. And with that in mind, it has also increases the attack surfaces. So first of all, in the 4G space or the 3G space, if you want to, let's say, protect three doors, but with 5G coming in with all the SPA, service based architectures and different interfaces, now you have to protect more than 10, 20 rooms. We don't know, and the network has also become distributed, from the bare metal. You are now seeing cloud native functions. ORAN is also coming up. There is also encouragement of multi-tenancy to optimize the cost as well. So there are different attack surface which has been exploded basically. And one of the like one of the recent attacks what we have seen is from a Salt Typhoon APT group, which has targeted the telecom operators inside the US. Basically, they have exploited the supply chain backdoors, and from the core routers, they have come into the network infrastructure, and they have exploited lots of like subscriber data, which is a national security threat, because they can easily intercept calls. If the attacker is inside your telecom network, whatever calls you are having, whatever data you are streaming, they can get a hold of all those information, which is very critical. And uh, not only this, they can also disrupt the services. So imagine if you are in middle of your uh, uh, like journey, you are going from place A to place B, and if you want to reach early, and you're relying on your mobile data to get to the internet, and if those services is disrupted, so you can imagine that this will impact the normal public and your day-to-day life as well as the one impact of the site can cause thousands of subscribers to not take the service. The telecom, like the telephony and the mobile service can get disrupted. So this can not only be impactful to the operators but also to the general public, and that is why the CISA has also given several warnings, and there is a lot of talk that has done for the Salt Typhoon, and this has not and it is not only just one APT. We have seen several of such APTs coming in and evolving. The one of the main cause of this is the attack surface has exploded, as well as there is so much to gain for the attackers, right? So you have social security numbers which you can take. You can take down the CDRs. You can take down a lot of information. So there is a lot of high stake involvement there, and that is why the attackers are getting active now. Now, if you look at the overall threat landscape, apart from the service-based architecture and cloud-native misconfigurations, we also see deep fake attacks coming in and evolving as well now. Imagine if there is a like AI avatar who is calling a SIM operator or a mobile operator to provision the SIMs, and he just will verify his face and his video information. And if he's looking legitimate, which you can do with the use of AI, he can easily provision the data for you, and you can have unlimited some SIMs provisioned under your name. And if those SIMs are not for the mobile devices, they are for the IoT devices. So those can be used against a network. For example, those same mobile phones or IoT devices which you will have where you are using the SIM, those can be used to carry out malicious attack on the network itself. And you don't need to go anywhere, because once you will get the SIM, your SIM will be registered, meaning it will get the signals, right? So you are already on the network, and then you are free to do whatever you can. So this can be very detrimental. So this is like just one example in which a fake video call used to approve enterprise SIM provisioning. So this looks scary, but this is really uh, what is happening these days. Now, one thing to understand is why do we care about this? And if this is happening now, can we stop by any means? Like, is there a way that if AI is being advancing so much and the attackers are using AI for their own use and to carry out some attacks, uh, can this be prevented? And we clearly see that there's a surge of these attacks coming in. From 0 or 2% it has gone to 6%. And it's not just happening in the North America region. It's been happening all over the world. So the important thing for us to understand is, can we prevent and detect such attacks? And the only way that you will be able to do it if you can understand how these attacks are carried out. So this is exactly what we'll be going to show you during some of the demo sessions here, that how the attackers carry out these attacks and what they can do after they get into the network. Okay, but before we go to the demo stage, I just want to take you through two different steps, starting from what is the entry point. For example, if there is a deep fake video or voice used to bypass the KYC procedures, in which the attackers gain valid SIM, eSIM identity. The example can be a ghost subscriber provisioned using AI-generated faces. This is a common example of the deepfake attack. Now, once the attacker is provisioned, once the SIM is registered into the network, the first step, what he will do once the SIM is registered, is that he can use that SIM to send some packets on the network, which is the core network escalation with valid SIM identity. This is the first entry point. Once the malformed packets entered into the network functions whom the packets are sent, either they can process those packets, which is the abnormal packets, or it can just discard those packets. So depending on how you have done the implementation, this can happen, both ways. The other thing the attackers can do is that from the same network function, if the compromised network function is taken down, that function can be used to carry out multiple attacks inside the network, which is the third scenario in which you are using stolen credentials or tokens to exploit other network function. This is the other form of the attack that can happen, after that. Then the other pieces of attack are the rogue NF registration, in which you can create multiple network functions. If there are, let's say, 5 to 10 network components, but if you are getting privileged accesses, and if you are literally moving inside the network, there's a high chance of you creating your own network components, and you can use then those functions to generate some malicious payload inside the network. So this can be scary, and this is happening actually lot these days, since the operators or the vendors, what we have seen is they are taking good measures, but the amount of attack surface, or I would say the attack surface, is widely distributed. So there is a highly possibility that the attackers can move inside the network, and some things cannot be or some guard rails cannot be in place, right? Okay, so just to explain some of the exploitation scenarios, for example, how the attack works, first of all, if you look at from the same example that what we have explained earlier, a deep fake attack in which the SIM is already registered into the network. The first step that you will do, you have to set up a session. The attacker, for example, observes or establishes a normal connection between the UE and the UPF, which is the user plane network, with the data travels. Whatever you stream, whatever you download, that is the data coming in from the user plane. And that data gives you the information of the TEID, which is the tunnel ID, which is used to identify the data tunnel. That is one piece of information that it can get. The other is the IP address of the UPF. So UPF is the user plane function which sits inside the data center of the operator. So once you are connected to a network, you will be having an IP address of that UPF, which is you can get on your mobile phone. Then what we can do is, once you are getting this information, the tunnel ID or the IP address information, you can use that information to create your own packets, and use those packets to insert a payload, and that same packet would be now sending to that UPF function. So this is something which you can do, and you can create strange packets which the UPF can process or not process depending on the implementation design of the network. So we have seen that if we are using fake TIDs or incorrect headers, large packets, there are there are some cases in which the UPF is crashed. They were not able to process the information. So this is a normal pattern what we have seen. And to explain this all, if I just take you through this example further, that once the packet is created now, you are now the attackers flush the UPF. You can increase the payload size, or you can increase the frequency of how much packets you want to send from your mobile phone or your IoT devices. And then depending on the implementation design, the network functions can crash, or it can force to process invalid data to other hop, which is it is processing the information and it is sending also to the other hop, which is also can be an issue. So this is something like a vulnerability which is exploited to gain the unauthorized access as well. And what do you observe in terms of the behavior? The attacker monitors the UPF to see if it crashes, process packets, or logs error incorrectly. So the behavior of the UPF would make the attacker understand that how the UPF is configured, and based on that responses, they'll be able to carry out more attacks, or maybe change the behavior of the attack. So this is something which you can also have to see, that if the observation is there of the UPF or not. Now, this is one example in which there is a attacker, which is the recent incident inside North America, in which he has used his mobile phone to get the IP address as well as the tunnel ID, and he has used those information to carry out or to create its own packet. And this is one example in which you can manipulate the GTPU header as well as insert your IP address and the GTP port information, and you can use just a Python script to send the packet towards the network, right? So this is as simple as this is how I'm showing you, and what is the action? If you will notice the trace on that user plane function, you will see there is some UDP packets which has been generated, so it it it, it clearly means that the payload what has been sent from the mobile phone has hit the UPF, and the UPF has now processing that information. So this is can clearly visible, and this is, by the way, this whole scenario we have implemented on our lab. So this is just like any other network which you can see inside North America. Now, if you look at if you look at scenario number two, which is uh, if the UPF or a network function which is compromised, and if that network function, uh, any communication happening to and from that network function can also be also be extracted, because in this scenario, if you notice this, we are also demonstrating one case in which you are exploiting the NRF token. NRF is the gateway which allow you to enter the control plane. So every time, let's say a UPF or any NF wants to talk to any other NF, it asks NRF that, hey NRF, can I get the token? I want to talk to Mr. A or Mr. B. Once authenticated, the NRF will grant the token, and then only the two network functions can talk to each other. Okay. So but if you are already present inside the network, that same token which is used to grant the rights can be extracted and can be used against you. So this is one example in which, if you see that phrase, you'll see this authorization bearer token. So this token is being used to send the request towards any other network function. Okay, so this is just a bearer token. Now, what I'll want you to see is to see that once you will be able to do the registration, you can use that same token to do the registration, and once you do the registration, you will be a part of the network, right? So this is like think of this like if there are 10 network functions which is making up the data center of an AT&T or a Verizon, and in if an attacker is coming inside that AT&T data center, and if it is have taken down one network function, it can use that network function as an attack vector, and that attack vector can then make itself registered into the network, and all the communication that has been happening across different routers or switches, those can be intercepted as well from that malicious network function. Okay, so this is one example of how this can be done, and there are different ways of how you can do this as well. The last scenario which I want to show you is of a DDoS like scenario, a denial of service, which is once you can not only send the malform packets, but you can also see like send unlimited number of packets, depending on what is your frequency or which tool you're using. So here, like this is an example taken from our simulation lab, in which once we have carried out a DDoS attack, we can easily see that there are lots of packets which has been sent, and the UPF is actually processing those packets. So it means that if we can increase the frequency of those packets, easily the network functions can be crashed. So this is, and it can cause service impact, meaning if you're using your if you're like browsing YouTube or watching your movie or talking to anyone, if your user plane function is down, your whole service will be down, right? So this is one example. So and this can be with these deep fake attacks and with these like AI based attacks that are like common these days. This is have become like a new normal in which these attacks are being carried out frequently. So we have to make sure that our network is able to detect such attacks as well as be able to prevent such attacks. Now, how would you go about detection? Because we cannot prevent the bad guys to carry out such attacks, right? We cannot invest a lot of like cash into protecting the data centers. We already have firewalls. We already have a lot of next generation security guardrails there. But there are some things which you can do, which I have listed here. For example, the best way is to like enable the logging. This is your like security 101. Like second is you have to install some sort of a monitoring tool. You can use either Elk Stack, Prometheus, or Splunk to ingest the logs which you are getting from that network functions. And then those logs can be then filtered out, normalized, as well as you need to have a visualization view that what are the abnormal logs, what are the like normal logs, and from there you have to detect the malicious patterns. Maybe you can use log parser, you can include your own rules, uh, like, and make sure that once you are configuring those rules and once you are getting those alerts, you need to have some alarms on top of that. You have to keep some alarm threshold that if, for example, the success rate in my user plane traffic goes less than, let's say, 60%, it means something is abnormal. Or if my CPU memory utilization becomes like more than 30%, it needs to get me some it needs to alert me on something. So you have to configure those rules if you have to have better detection process inside your network. One of the other techniques, what I would suggest you here, which is prevention. You don't have to just rely on the detection techniques. You can also enable prevention techniques as well. And so we have seen there's a lot of cloud native like functions and cloud native controls that are implemented. So if you are using containerized network functions and Kubernetes in your platform layer, you can create network policies which will allow you to, like whitelist the traffic, what your network is getting, or you can also like enable some sort of port, like ports which are only allowed or not, right? And you can also implement some rate limiting feature in which you can, like in case of a normal traffic, this is the uplink and downlink speed that you can get. But if the speed or if the bandwidth goes up, that means that it is some abnormally, so this is something which you can also configure in your network function. Some of the defense playbook, what I suggest is, because there are attacks coming in from all directions, right? The best practice, what you can do is to enable security by design practices, and how you do this is by implementing threat modeling earlier in the design. And there are different techniques of threat modeling which you can use. I would suggest you can make your own threat modeling methodology, not just rely on the traditional methodology like Stride or PASTA techniques, because like telecom protocol stack is different from any other stack, so we have to understand this. uh, this stack is being built by 3GPP like standards, which is the telecom standards. Then we also have ORAN standards coming in. We have SCAS compliance. So make sure that your threat modeling techniques are including all these security standards, but the telecom world. Okay. And the output of this is that by doing the threat modeling, you'll be able to identify the weak surface. That, hey, for example, if my network is capable to withstand a DDoS attack, but the authentication authorization checks are not properly implemented, so there is a weak point in my network, right? So how do we how do we protect against such thing? By prioritizing and including security testing into your design as well. So once you identify that like the weak surface by doing threat modeling, the second is to make sure that you are actually uh, exploiting those things and making sure that whatever you have identified is making sense for you, because there is no point of coming out with 100 risk, or 500 risk, or weak surface, because your uh, network application team will not agree with you, and nor you will get the funding for your security projects, right? So you have to come up with some quantification metrics. And how do you do this? You have to include some fuzzing, red teaming, just to make sure that whatever risk you have identified is making sense for you, is actually being exploitable or not. And thirdly, I've seen lots of detection tools that are being implemented on the application level, like layer, which is the upper tier of the network. And there's a lot of things that are missed from the application layer, because any calls, any process that are running, it goes data goes from the application, from the user space to the kernel space, and all the sys level events happening, is happening on the kernel level. So it's better to have a call level like detection, in which whenever you whatever syscalls you are getting, make sure that it is also detecting on the kernel space as well, which is the real like tier where the whole logic sits. And lastly, I'm a fan of zero trust. So whatever you do, think of this like an attacker is already present inside your network. Okay, because now, like, gone are the days where we rely on the perimeter security. You know, and with this AI and the deep fake attacks that has been common these days, we already know that the attackers are inside the network. So we have to think from that perspective, in which we have to implement segmentation, implement continuous verification, and make sure that you are like implementing like the least privilege principle, and that is also part of all the zero trust methodology. The key takeaways which I would like to give you from this presentation is that 5G is critical infrastructure. It is the enabler of several industries which our lives rely on. Healthcare, manufacturing, financial. So it is about national security. Whatever will happen on, if the 5G network is compromised, your national security is at stake. So this is very serious thing. Okay, and threats like Salt Typhoon, deepfakes are already here. It's not about, we are talking about like 10 days or 10 years before. Or it's happening right now. So we are constantly under attack, and we are seeing, like, if you will go if you will visit the threat intelligence reports of CISA and DoD, you'll see the new APTs are coming in, and this is high time that we should take telecom security seriously. And defense is like a continuous practice. Continuous assurance is the key. And above all, the best way to prevent the bad guys is to be collaborative in what we do. It's about collaboration with operators, vendors, local agencies, as well as like the education community as well. And if we have to, push the attackers, we have to all come, unite and come front as one strong, arm, and be able to, and then we'll be able to protect our critical infrastructure, right? Okay, thank you, everyone. Take a very good care of yourself.